Okay, nice. Hello. Uh, Today, let's go to see what is our final project goal. I'm gonna show you the screen. Um, Here in this YouTube channel. Blah, 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 blah. Uh, Here, let me see 1 second. This does. Here, these two videos, the number 9 and number 10, are the type of exercises we will do for this final project. Okay, is first one probably will change a little bit, but this is the idea. Do you remember? No? Can you see this video or no?
Yes.
Yeah. I don't know if you remember this film. Water Jack Problem Die. So Die Hard is the name of the film. It's I will try to show you this video. It's Die Hard. Die. Sorry. Let's try to find here. Sorry. I want to go out from my channel. Want to go to YouTube. Yeah. Okay. Die Hard. Okay. I don't know if the audio will be. Let's go to try. If you can see. Advertising for us. Okay. This is I'm going to tell you what is the situation. They are a bomb. They are next to exploit, and they have to resolve the problem. The problem is there are 2 gallons of water. The problem to resolve is to have in the five gallons bottle exactly 4 gallons. I think this idea to have here exactly 4. This is to have here 4 gallons and put in the scale, and if that is good, they can deactivate this bomb. You see this film or not? You remember that? Okay, and what we have to do is use Prolog to resolve this type of problems. And this type of problems are the name are this name is state problems. There are many problems you can resolve with these techniques with Prolog, and I'm going to show you how you have to build this type of exercises, and I can show you or give you several options to your projects, okay? But this is the idea. Probably you have to resolve one or two, depends of the difficulty of this exercise. This is your final goal for this subject, okay? This is the idea. We have some exercise we didn't finish last day, no? We can try to finish the last day exercise before and see what happened with my state. I see if I feel good or not to continue. Okay, what do you remember the exercise we did last day? And
we wanted to insert an element in a sorted list.
oh, okay. Insert one element in a sorted list, and we have the solution or not? Which I do no.
No, we didn't have any solution.
Okay, we have the sort by insertion. Okay, insert in a sort list. Do you want to take some minutes to try to resolve by yourself? You want to try to resolve? You know the idea, you have to insert one element in a sort list. You have to think what is the most simple case to insert one element in a sort list. What do you think will be the most simple case?
If we have an empty list and we just put the element inside of it, so the list is only of the element.
Yeah, that will be one option, but there one more generic case. If you have one element you want to insert and the list is a sort list, what happens if the element is less than the first one? What is the position you have to put?
Then it will be positioned first.
Okay, this will be the most simple case. If the element is less than the first one, we have to put it just at the beginning of the list. If not, we have to insert in the tail of the list. So we have two different cases. The first one is the element is less than the first one, and the second case, in other case, different case than to be the less than the first one, is to insert in the tail. Okay, take some minutes to think about that and try to resolve by yourself. And after that 5 or a little bit more minutes, let's go to see what is your solution. Let's go to try to finish if you have any trouble. Okay. Okay, perfect. See you in 5 minutes, a little bit more. Okay.
All right.
Okay. Hello. Do you have the solution or any approach to the solution?
I have something, and it kind of works, but I also have like a small problem.
Yeah. Can you share your screen? Let's go to see. I want to participate more people. Probably if I will ask to someone more, but please share your screen if you. And let's go to see what is your approach.
Yes. So at first I have this empty list. So in case if it's empty,
Yeah.
then it puts it inside of the list. And then I have the case where it is smaller than the head. So
Perfect.
it puts it to the left. And then I just have, so that it's iterative, I just have this line, but I don't know, something isn't really working because I have a lot of solution and the first solution is always right. But then I have like some different solution that are not right. So I don't know what.
Yeah. Yeah. What happened here is first in line number 2,
Yes.
will be better instead of only put the symbol or the operator less.
Okay. Yes.
Less
Like
than
this.
equal. Yeah, perfect. And in the other option, you have to write what happened is if x is greater than
Okay. Great. Then y.
yeah.
Oh.
No, that's perfect.
Yes.
Is after, you have to write that after. Yeah.
So. Oh. Oh.
Nope. This is so the tail. What happened if the element is x is greater than the first one?
Oh, then we have to. Then we have to see if it's also greater than the tail or not.
No. You only have to insert in the tail. That's all.
Oh, okay.
That's all. You don't have to check if
All
it's
right,
greater
because
than
we
the
only
tail.
have yes. Okay.
No, but it's not. This is not the way to insert in the tail. You have to call after the. You have to change the dot for a comma here, and insert element x in sort list. X in the tail.
Okay, so then I
no.
then like this or what?
No, only in the tail. No, you have to put here x. Remove this bracket. Okay, and insert in the tail. That's all. And when that is true, here you have a solution because you have there 3 arguments. When that is true, when you insert the x in the tail, you need a new variable. No. In the right side on line 4, the after tail, you need another. Okay, here. When that is true, here you have a result, a new variable. You need there a new variable. Exactly. When that is true, inserting sorted, that is true. What do you have in R? What do you have there in R?
Then we have a list of x of the tail which is x.
Yeah. When that is true, you have X inserted in the right position in the tail. No? Okay, perfect. And what do you have to do in the left side here? Yeah. What do you
Is it
have to?
also R? Oh no, only also Y, right? Right and
You
Y
need.
and
Yeah. Exactly. Exactly.
like this.
Yeah. Perfect. And you don't need the line 6. It's more or less. Yeah. You can delete that. Okay. That's all. You have two cases. What happens is if X is less or equal than Y or the head, I prefer I prefer you call that head because it's more clear. It's like, yeah, try to use yeah, try to use name of variables that can help you to identify what are you doing. So, and I prefer to write directly head.
Okay,
No,
yeah, sure.
yeah, will be more clear. That is important too. When you're programming, it's interesting to leave things very clear.
Mhm.
The same you have to change. No, it's okay. It's okay. It's okay. Perfect. That's all.
Okay, then
You can check if that works or not.
Still the
yeah.
y from the equation.
Okay. No, it's not the tail. That's not good. It's not good. Here is the head.
Oh yeah, sure.
Head. Yeah.
Confusing. Okay.
Yeah. Yeah. No. It's okay.
Okay. Okay, now it looks good. It looks better than before. Okay,
Perfect.
nice.
Now it's working. No. Okay.
Yes, now it's working. Thank you so much.
You can put another example if you want.
Yes, sure. Wait. Mm.
Okay. Okay. Perfect.
Yes, nice.
Nice. Perfect.
It's
That's
working.
all. So you only need these three cases. First one, what happened is if you have an empty list, that's perfect. Line one. Line two, what happened if the element you want to insert is less than the first one, than the head. So in this case, it's very simple. It's only put before. It's the most simple case. And the second case, sorry, the third line is what happened is element is greater than the head. So in this case, you have to insert in the tail. So you only have to call to insert in this inserted with element X and tail. And when that is true, there you have the solution. You only need to put the head before. It's very interesting. It's like more uh, declare or define what you want to do and not exactly what is the way to do. Or it's more put the focus on what do you want and not in how you can uh, resolve that or do step by step the solution. Okay, nice, perfect. So um, I want to. What happened today with the cameras? What happened to the? You don't want any more the extra point? But um, okay. this is the first part of this problem, but we need something more, no? We need something more. I'm going to share the screen. We need something more. It's so remember, the idea is we want to sort by insertion. So we have a list. We take the first one, we sort the tail, and after that, we have to insert the head in this sort list. Do you think you can finish the algorithm with the if you have already implemented this insert inserted? You think you can finish by yourself this algorithm? The only need, the only thing you need is separate the head, leaves, and the tail here. You have the head and the tail. So what we have to do is sort by insertion the tail, and when we have the result, we have to insert the head in the tail. Do you understand that or not? Do you understand what I mean? How to resolve this predicate? Natalia, Liva, Milos, Benjamin, Natalia, Sawatka, Adriana, Elsa. What do you think?
I guess we can try.
You can try. Okay, I'm gonna give you 5 minutes more, a little bit more probably if you need. Let's go to check if the solution is good. And if not, let's go to resolve, okay? So see you again in 5 minutes. Do you have the solution? Please, someone who try to resolve. Doesn't matter if you don't finish.
Yeah, I have an idea, but it's not working so far. I can show.
Okay. Can you screen?
Okay, so I looked at the bubble sort to get the first line because I wasn't sure what's the easiest case, so I copied that a bit. Okay, so pretty much recycled the first line, also edited, entered the sort list. And as the
but in this case, the idea is a little bit different. It's not exactly the same because it's not exactly because Bubble another way to resolve is like this sort list, but in this case we don't need to check if the sort is we have the sort list. What we have to do here is first separate, as always, or think about what happened with the empty list before. What happened if we have an empty list?
Then it just returns the empty list.
Nice, perfect. And after that, let's go to use induction. In this case, separating head and tail. So it's another case with insert sort. And now we have to separate head and tail. Perfect. And leave the result, leave some blank space there. No, it's perfect. It's better to leave some and okay, perfect. Because what we have to put there in the solution depend of we are going to write the right side of the rule. So what we have to do here is ask to the n-1. In this case, ask to the tail. What happened if I we sort the tail? Try to insert with this algorithm, insert sort the tail. Perfect. And when that is true, you can put there a new variable, for example, air or whatever. Okay, nice. When that is true, what do you have there in air?
The sorted tail.
Exactly. And what do you need to get the full list sorted?
Insert the head into R.
Exactly.
Let's head R2 and
Nice.
here
Super. That's all. You can delete the other line.
I think I had the same idea. I just didn't get the first part with the separation here. I copied too much from the bubble sort where we used the append statement.
Yeah, it's very similar. Yeah, you have the idea. Yeah, you have the idea. You only need to modify a little bit, but that's all. You can check that now in Prolog.
All right.
It's okay.
Yeah, looks good.
Okay,
Thanks
nice, perfect. It's really so simple. You only what we only have to do is use induction and sort the tail and think, okay, if I have that solution, what I have to do to get the full list? You only need to insert the head in this sort result of the tail. So that's all. Okay, it's always the same idea. Try to use induction. Usually we're going to take the head and the tail. Sometimes, that happens in the case of bubble sort, we change a little bit because the induction there was built using this base case with the sort list and tried to replace any single consecutive or any consecutive pair of elements, replace the case that are not good. It's a little bit a special case, this bubble sort. Usually we take head and tail, adds to the tail. When we have the solution, we have what we have there in the tail, the result of the tail, and what we have to modify or what we have to add to the result of the tail to obtain the result of the full list. You did perfect. Okay, Alexander, thank you. Very good. Okay, let's go to do a next exercise. I'm going to share my screen. Please, I need your feedback for the rest of the people. Any question? Any question, Laura? It's okay. You understand the idea? Okay. Natalia Sawotka. It's okay. Nice. Liva.
Yes, it's okay.
It's okay. Sure. Benjamin.
It's okay too.
Okay. Any question, Milo?
Yes, I think that it's clear.
Okay. Nice. Natalia.
Yeah, it's
Natalia
okay. I need to
Posier.
learn slowly,
It's okay.
but
Adriana. Sorry, you need to?
It's okay for me.
Okay. Elsa. Nice. Perfect. It's okay. Very good. So happy with that. Okay. Exercise. After that, we have enough knowledge about to deal with list. State that are based on in. So this is our last. We're going to do only with lists. Okay. So this next is the most the fastest sort method is called Quicksort. Quicksort. And I'm going to explain you the idea of this algorithm. It is very simple. The idea of quick, we have a list of elements, for example, like that. And 2 and 9, wherever we have an idea here is try to separate lists in two different parts. The ideal option here is to take the element that separate the list in two parts. It's like the elements that are less than this element, like for example, grade. Sorry. Let's go to take one element. We call this element pivot. In this case, what is the element can separate the list into equal parts? Like, for example, the number 4. If you take the pivot number 4, we can separate into the original list in two different lists. Like the list that have element less than 4, that will be 1, 3, 2, but 1, 2, 3, 2, and 4, that will be less or equal. And the other list will have elements that are greater than this pivot, like 5, sorry, in order will be 7, 5, 8, and 9. And after that, what we are going to do, we have to do here is try to sort this first part of the list with 1, 2, 3, 4, and sort, Quicksort that the result, and Quicksort the second part. That will be 5, 7, 8, 9. And when we have these two different separate lists, the list of elements are less than, sorry, the lists are great than the pivot. And finally, what you have to do is put everything together. Is the list 1, 2, 3, 4 in the middle, and 5, 7, 8, 9. So what we need before is create a predicate to separate. It's like something like my split, something like that, that can take a list of elements, pivot, and can separate between the element, those major or minors, major elements. That will be input, that will be another input, and that will be output, that will be output too. So the idea is, it is true if minors unify with a list that contain the elements of a list that are less than 5, less or equal than the pivot, and major unify with a list elements of list that are greater than the pivot. Okay, this is the idea. The idea is create a predicate that will receive a list, and this pivot, a number, can separate in this minor of equal of this pivot and major. In this case, we are not short. We don't. In this case, we don't sort the elements. Only separate between the minors and majors than this pivot. I'm gonna share to you this explanation. You can use in your code if you want. Okay. Do you think you can try to resolve that by yourself? This first part of the algorithm, try to split the list with this number. Try to do by yourself. I'm gonna give you some minutes, 5 or probably 10 minutes to try to resolve. And after that, let's go to see what happened. If you have some approach, let's go to, or you finish this predicate. Please don't forget to use induction to resolve that. Okay. So see you after 5 or 10 minutes. Okay. And see what happened. See you then. Any solution? How are you?
Well, same last time. I have an idea, but it's not working quite well. But
the other one that have a try, please, someone who can share idea or no?
Maybe I can try, but I don't know if it's good.
Okay, please, Natalia, try. I'm gonna please share your screen. Let's go to see.
Okay, yes. Can you see it?
Yeah.
Okay.
Yeah, perfect. Perfect. The only thing, please change, because you put before the pivot, and in the definition we put right before the list.
So
you can change of, okay. Okay, let's go to see first line. After that, we can change this definition. If the empty list, if you have the empty list, you there the result will be 2 empty lists. That's perfect. It's okay. the second rule, second line, if the head is greater than L element, that means you split the tail, that's perfect. And in this case, you put the head with the major, perfect. And the other one is the next one, because these two lines and the previous one are from the same rule. And the next one, the head, the tail, if the head is less or equal than the element, in this case, exactly, the head go with the minus. That's perfect. Can you check if that works?
Yes. I need to share again, yeah?
Yeah, I don't know. You have to choose the other window, probably the window with Prolog.
Second. Okay. So my split and
List, a perfect list. You write first the pivot. You change the order.
So
You need to put here.
here, like this.
Yeah, and you need in the list elements greater than 4 and less than 4. So you had a biggest list.
Bigger than 4.
Yeah, right? With more
Okay.
elements. With more elements.
Okay.
Like to see what happened.
Sorry. Yeah, that's
A little bit more because yeah, because you are going to separate. Okay, that's really nice.
and that's
then,
it.
No, now you need two lists.
Okay.
Two variables is like, but no.
Less with okay.
Two variables, only two variables.
Like this.
No. To check, no, to check that you need there two variables. For example, m, the minors, or me, mi, two variables. For example, delete this bracket because variables don't need.
Okay.
No, okay, is in capital letter. No, two variables, only two variables. The first one will be mi, for example, minors.
-1.
No. Only two variables. Only two variables. For example, m.
You mean?
You're going to get the minors. I don't know.
I don't understand.
Minors,
sorry.
Okay. This algorithm will split the list in two different lists. The list that have the minors than 4, and the list that have the majors than 4. So now you need to write two variables. For example, if you want minors and majors, with starting with capital letter, that means that it's a variable.
Okay. So like this?
For example, yeah.
Okay. And now I close it.
And dot at the end. Perfect.
Okay, sorry.
Okay. Okay, that's it. That is the solution. You have 1, 2, 3, 4 that are minus or equal than 4, and 5, 6, 7 that are elements that are greater than 4. Okay?
Okay.
That is what we need. And now, after that, we can resolve, is more or less easy, the algorithm to sort any list using this mySplit. Yeah, I can, if you let me to share, if you finish
Okay,
to
yes,
share the
sure.
screen, okay? I'm gonna show you next step. The next step, we have this mySplit, and the next one is to Quicksort. Let's go to Quicksort. See a list, and have a result, and it is true if result unify with list that contains the elements of list sort from less to high, for example, elements to higher. Okay, the idea is take a list and obtain a new list that get the same elements but in this order, from less to great. Great elements. Okay, and the way to do that is first take this pivot. In this case, let's go to take the pivot. Let's take the pivot as the first element of the list, because there are a theory that say that if you take the pivot, the first element, in many cases in the medium case, this algorithm will work faster, because take the best pivot need to each time, because we're going to repeat this process of take the pivot in every single recursive call. Take this pivot, the best need many time. So the usual way to obtain that is get the first one. So we separate the first one and the tail, the head and the tail. The head will be this pivot or this element to separate. After that, we're going to split the list in two parts, and after that, we have to quicksort any single part of the list, and after that we will get this part of the list sort, and the second part the major sort, and the only thing we need to finish is put everything together with one append. Is the minor, the pivot in the middle, and the major. Do you have the idea, more or less? Do you understand this idea? Any question? Do you have any question to do that? It's okay. Okay. Can you try to resolve by yourself in 5-10 minutes and finish? After that, let's go to resolve. If you have any question, you can resolve after that. Remember, this is probably the fastest way to sort a list in with a computer. This algorithm is called Quicksort. It's very fast, very simple. Separate the minor and major elements of a list. After that, sort these two parts, and after that, put everything together. And that's all. Okay. 5-10 minutes to finish. Okay. Any question? No? Okay. See you then in 10 minutes. Anyone have the solution? If not, if you don't have the solution, doesn't matter. Yeah, you can share your code and try to finish. Hello. Laura, you try.
I have no idea this time, so I can't share anything. Maybe we can have more time.
Yeah, we have, yeah, if you want, we can leave here the session and try to finish next day, okay? I think will be good. You can try, think a little bit more about that. We can finish there here because we are around 5 minutes to finish. And next day, let's go to finish this exercise. And we're going to start with the state problems that are the type of problems you have to know to resolve this type of games, like this hard eye example I show you today. So today finish with this, or this is the last exercise we are going to do with list. And after that, let's go to resolve exercise with these state problems, okay? So nice, perfect. See you next day. Okay, any question? You have some question?
Yes,
No?
sorry, I was in another meeting. What have we done? So I can revise it on YouTube, right? I can
Sorry,
look
can you
it
repeat?
up the session again in YouTube, right?
Yeah, you can
Okay.
see again in YouTube. I'm gonna
Okay, great. Thank you.
upload to YouTube. Okay.
Okay.
Nice. Perfect. See you next day.
See you.
Okay.
Bye.
Nice. Bye. Bye. See you.
Bye.
Bye.